Hello and welcome to another Math 121 workshop video. Today we're going to look at this example where there's a Pew Research Center survey and it shows a big gap between Democrats and Republicans' opinions about climate change. So we're going to take a look, and the first question I asked you here is the two percentages that this survey reported, that 84% of Democrats and Democratic-leaning independents believe that global warming is a major threat to the United States versus only 27% of Republicans and Republican-leaning independents. Those are both sample proportions, right? They both came from this sample of adults that were contacted on the phone. And they may not be the true percentages if you were to get your hands on all the Democrats and all the Republicans in the population. So if we want to know something about the true percentages, we need to make a confidence interval. And so I asked you to do that. I asked you to make two different 95% confidence intervals, one for the Democrats and one for the Republicans. To do that, you have to use the right formula, and I'll pull up the formulas here. So we have this interactive formula sheet. This week we're working on the last two formulas, the two sample formulas for proportions. But this question I'm asking you to do right now is actually a one sample confidence interval. I'm asking you to make a confidence interval for the one sample of Democrats and then separately for the one sample of Republicans. So once you identify the formula and you know it's a confidence interval, you're going to use that, and you can do your calculator, or you can just use this tool on my website to make it a little easier. Okay, so I'll go ahead and type in my numbers. P hat is the sample proportion. For the Democrats, it was 84%. Now, you can't type in 84 because that's not actually the answer. It's right 0.84. Because if I put an 84 in here, 1 minus 84 would be a negative number, and you can't take a square root of a negative, right? So just make sure you always put percentages into the formula as decimals or fractions, but not the percent number. Okay. 95% confidence interval, we know that Z star is 1.96. You can always look it up at the bottom of the d-distribution table, but that's one you might want to know. And then finally, the sample size. If you take a look at the data here, it said that 683 of the people surveyed said that they were Democrats or Democratic-leaning independents. So that'll be the sample size, because this is the one sample of just Democrats. So I'll come back over here, and 683, hit enter, and there we go. There's our confidence interval. It's 84% plus or minus about 2.75%. And if I just use a calculator here, I can do that math. So 84 plus 2.75 is pretty easy. Let's just do minus 2.75, hit enter, and there we go, 81.25. Okay, so I can start typing my answer. So from 81.25 to, and then if I added it, I guess it would be 86.75, and then these are both percent, so percent of Democrats believe climate change is a big problem, is a major problem, period. Excellent. And I'm a little perfectionist, so I'm going to move that so it actually fits on the page. Okay, excellent. So there we go. That's what it is for the Democrats. What about for the Republicans? Do the exact same thing, but this time with the Republicans' numbers. So now there's only 27% of the Republicans who think it's a major problem, and that was out of a sample of 691 Republicans or Republican-leaning independents. So I go ahead, pull up the formula. I'm going to clear out these numbers now. It's 27%, still 95% confidence, so still the same Z star, but the sample size has changed slightly, and I hit enter. Notice I'm not doing a +4 confidence interval because I don't need to. The sample size is really, really big here. 600, almost 700 people in each sample. There's no difference if you make a +4 confidence interval. It really won't change your numbers very much. So, okay, so this looks like 27% plus or minus about 3.3. Again, let me use a calculator and do the math. 27 minus 3.3. I mean, I could do this without a calculator, but it would take me a second. I might make a mistake. So there we go, 23.7%. All right, so I'll start typing this. So for the Republicans, it's from 23.7% to, and then if you add it, then you're going to be let's see, I can pull that old equation back up and I can change it to a plus sign. There we go. And 30.3, yeah, to 30.3% of Republicans, and I'm just assuming that you understand that this is both Republicans and Republican-leaning independents, believe that climate change is a major problem. Cool. Okay, so we're done. We're pretty confident that these two intervals are going to contain the two different population proportions. All right, and you can see, wow, that's a big difference. Over 80% of Democrats, but probably less than 30% are Republicans. So that's a big gap. And so that's my next question. So actually, how big is that gap? And now, to answer a question about how big a gap is between two population proportions, that's where the two-sample confidence interval comes in. That's exactly what the two-sample confidence interval is designed to do. So if I look at all my confidence interval formulas, I have the original two were for means, but we're not talking about means anymore, we're talking about percentages. So the next two were about percentages, and now we're talking about a two-sample comparison of two different percentages, right? We have the 84% of the Democrats versus the 27% of the Republicans, and now we want to see how big the gap is, and so we take the difference between the two sample proportions, but then we realize that's only in the sample. We need to talk about how big the gap might be in the population. And so we're going to add and subtract a margin of error that'll tell us how big that difference in the population might be with a 95% confidence level. Okay, I've got all the numbers that I need. P1 is just the Democrat number, 84% of Democrats. P2 is the Republican number, 0.27. Republicans believe that climate change is a major problem. Z star is still 1.96. We still want a 95% confidence interval. It's still a Z value. You still look it up the exact same way. Nothing's new. And then the two sample sizes. For the Democrats, it was 683, and for the Republicans, it was 691. Once I have all my numbers in place, I just hit enter, and let me move this so we can actually see the result. There we go. That's the result. So that goes, if I add these together, what is that? 61.4, and if I subtract them, it's going to drop me down to, let's just do it, clear this, 57 minus 4.3% would drop me down to a 52.7. So there's my confidence interval. Let me write that down. So the confidence interval is from 52.7 to, and then if I just do that again and switch this minus to a plus, what I just do it in my head, what is that, 61.3? Yeah, 61.3%. Okay, so that's my confidence interval, and now I've actually asked you to do something slightly more complicated. I've said write your answer using a sentence that clearly explains what we are 95% confident is true. And this is a little tricky because this new formula, this two-sample confidence interval formula, this guy, is something that it takes a little bit of thought to understand what this is all about. What we're talking about here is we have two different percentages, one for Democrats and one for Republicans, and there's a gap between them. In the sample, the gap is 84 minus 27, and if I just use a calculator for that, 84 minus 27, what is that, 57? Yeah, 57. So there's a 57% gap in the sample, but that might not be the true gap in the whole population. And so what the confidence interval is doing, a two-sample confidence interval tells you what the gap is in the population. Okay, so when I write a sentence to explain this, I should say something like, I am 95% sure, assuming that all the assumptions of the confidence interval are correct, and we'll talk about those in a minute. But assuming all that's okay, I'm 95% sure that the difference between the percent of Democrats, I don't know how to speak, they're Democrats who think climate change is a major problem, and the percent of Republicans who think the same thing is between those two numbers. And so let me go ahead and just copy, let me actually just cut those two numbers and then get rid of that and make some space so that I can put that answer at the end of this. Okay, so between 52.7 and 61.3. All right, as always, when you write an answer, you should double check it, read it, and make sure it makes sense. I'm 95% sure that the difference between the percent of Democrats who think that climate change is a major problem and the percent of Republicans, there should be an S there, is between these two numbers, right? So another way to say this, it might even be a better way to say it, you could say something like, the probability that a Democrat thinks that climate change is a major problem is between 52.7 and 61.3% more than the probability a Republican thinks it's a major problem. Right, so Democrats definitely are much more likely to think that this is a problem. They're between this and that percent more likely to think it's an issue. Okay, so that's interesting. That's a huge gap. Interesting enough, when I looked at this data, this was a survey about lots of potential things that could be major problems for the United States in the future, and this one looked like it was the issue that had the biggest divide between the two political parties. So other things Democrats and Republicans agree on more. Climate change, not so much. So kind of interesting. Okay, according to the Pew Research Center, this survey was conducted by telephone using random digit dialing combined with a pre-selection process where they selected phone numbers to try to get the right percentages of people of different racial and economic status and the right ratio of landlines to cell phones. And so, of course, they're doing all that to try to, get a good representative sample. And so I asked this question first. I say, why do we not need to worry much about random error in this example? And random error is something that mathematics can deal with. All of these formulas that we've been working with on this formula sheet, they're just the mathematical formulas that deal with random error. They just deal with the fact that when you take a big enough sample, you have these roughly normally distributed sample means or sample proportions, and then you use the bell curve model to sort of say something about how much random error there might be. And so we don't need to worry about random error because we've dealt with it with a confidence interval. Okay, so we could just say something like the math of the confidence intervals is designed to deal with random error. So as long as the assumptions of the mathematics are valid, as long as we can use the normal distribution and trust that that's going to work, then we're in good shape. And we can do that because the sample sizes here are just huge, right? We've got 1,500 adults were surveyed. There were almost 700 Democrats and 700 Republicans in the survey, and these are decent sized percentages too. So we're talking about 100 successes or more and 100 failures or more, right? These are really big numbers, especially when you realize that, the guidelines in the book say you really just need like 10 successes and failures in each group. So we're much bigger than you need. So the math is designed to deal with random error, and the sample sizes are really large here. So there won't be much random error to worry about. On the other hand, there is another problem with samples that could be a big problem for this survey. So what is that other problem? So what are the two sources of sample error? There's random error, which we're not worried about, and then what's the other one? Yeah, it's bias. Bias could be a very big problem. The only way to avoid bias is to do a simple random sample of the whole population. In order to do that, you would need a list of all the Democrat and Democratic leading independents and a separate list of all the Republicans and Republican leading independents to get the two things to sample from. And then you need to go out and track down those people and actually talk to a random selection of them and insist that they answer your questions. And if you realize that's not what they did here, they just tried their best. And then they, what does it say here? It says they used a selection of phone numbers that they sort of carefully chose, and then they did random digit dialing. So they did do a little bit of random generation, but of course, even then, if you randomly contact people, they might say, oh, I don't want to talk to you right now. Or maybe the only people who really wanted to talk were the really opinionated people, or maybe just people with a lot of time on their hands. But whatever reason, this probably isn't a perfectly representative sample, and so it could be biased. So the answer is there could be bias in these responses. And there are lots of reasons why there could be bias, and any kind of bias could be an issue that would make these confidence intervals not really super accurate. So that is definitely something to worry about. Okay, as always, let me know if you have any questions about what I did here today, or anything else in the course that's giving you trouble. Talk to you guys later.